Hi, welcome back to Calculus. Today we're going to continue looking at infinite series. We're looking at section 9.3, the integral test. So we have to kind of set the stage here a little bit, and we'll get to an example where we use the integral test in just a minute. But let's suppose that we have an infinite series with all the terms being positive, greater than, or at least not negative, greater than or equal to 0. This is going to give us a couple of things. Each partial sum has to be bigger than its predecessor. That's because if you keep adding positive things, your sum keeps getting bigger. And so we have a monotonic sequence of partial sums. Now, a corollary of that is that then a series of non-negative terms converges if and only if its partial sums are bounded from above. So if you can figure out what the partial sums are, if it's bounded, it's going to converge. If it's not bounded, it's going to diverge. Case in point, the harmonic series. So the harmonic series is just the sum of 1 over n. In other words, 1 plus a half plus a third plus a fourth, a fifth, a sixth, and so on and so on and so on. This is going to be a divergent series, and it's going to be one of our favorites as we go forward. And it diverges because its partial sums are unbounded. And that's because you can always group enough terms that will add up to more than a half. It's really easy to see at the beginning of the sequence. It takes more terms the farther out you go, but you can always do it. So the first term is 1, that's bigger than a half. Second one is a half, that's, well, not bigger than a half, but it's greater than or equal to. But then if you look at 1/3 plus 1/4, if you add those together, you get something bigger than a half. For the next one, you have to do a fifth, a sixth, a seventh, and an eighth, but it all adds up to something bigger than a half. And so if we add an infinite number of things together that are bigger than a half, it's going to grow forever. And so this is a divergent series. All right, so on the next page, we will actually get to the integral test.